Let's try to solve a Leetcode problem today. So today's problem is about how to implement a trie, number 2. So trie is also called prefix tree. So let's first try to understand the API. So for the trie, so here is the initialization. We're going to initialize the trie. And this is just an insert. It is a normal insert. And this is the count word equal to. So this API is to count how many words equal to this word. So for example, if the word is apple, we're going to count how many apples, and this is a prefix, we're going to count how many prefix, and this erase is just to delete the word, and this word must exist, yeah, because it is a set. It erases the string word from the trie. And let's check that the prefix length and word length is less than 2000, and there will be 3 times 10 to the power of 4 counts. So this means if we use a trie, it should be no problem. Yeah. And also we need to know that it is guaranteed that all function calls to erase the string word will exist in the trie. So that means if we use erase this function, the word will always inside the trie. Yeah, we don't need to check the error cases or edge cases. Now let's just start implement the trie. Normally for the trie, we're gonna prepare a trie node. So let's just prepare a trie node. So the trie node would be, yeah, let's just initialize the trie node. We're gonna prepare self.children as normal. Should be equal to empty dictionary, and we're gonna use. We don't need to use the addable word because for this problem we are not going to search if a word inside a node. We're gonna. Yeah. Also, we use a search, we can use another one. We're gonna use a count word. So this variable is just needed to count how many words. For example, this is the apple. We're gonna count how many apple. Yeah. So it's gonna be starting from 0. So we don't need to prepare addable word because this count word can used as addable word. Yeah. If it is more than 0, it means it is must be an addable word. So we're gonna also use the count the prefix because we also need to count the prefix. We cannot use one variable, just, for example, just count. We have to use 2 variables because the word and prefix they are different. Let me make a drawing. So for example, so this is a trie. We are starting from this is a trie. We are starting from character A, and then there is a character B and something, etc. We want to check the count word. So for example, AB is a word. Yeah, but what if there is a ABC? So ABC is a word, but AB is just a prefix. It is not a word. If we use this AB to count as word, it will have duplicate because some of them will be prefix. So we have to prepare 2 variables. One is the count word and another is count prefix. Yeah. So this is one problem maybe you're gonna make. Yeah, because for a trie problem, if you make a mistake, it's really difficult to debug. Because this testing case is small, you're gonna debug easily. But some other testing cases would be very long. It's really difficult to debug. So we have to think carefully about defining of the variables. So for example, count word is different from count prefix. Now let me get started for the main part of the trie. So we're gonna prepare self.root should be equal to the trie node. And then we're going to prepare the insert. So the insert is just as normal insert. The only difference is that we need to count word and count prefix. So I'm going to prepare a current should be equal to self.root. Yeah. And then for character in word, we're going to check if this word is inside or not. Yeah. So if say not in current.children. Yeah, if C is not inside, what are we gonna do? So current.children C should equal to trie node. Yeah, but if it is inside, what are we gonna do? So the current should equal to current.children C. Yeah, because we want to shift the current. So current is just starting from the root, and then it will go inside the trie. Yeah. But from here, it's not the end, but we need to prepare the count. so we're gonna count the prefix first. Yeah, should plus equal to 1. So while we are inserting a word, for example, if we are inserting a word during the try, for example, A, B, C, so for A, we're gonna count the prefix plus 1, B also, C also, yeah. But if we go out of the for loop, we also need to prepare the word, because up to here, we need to record current dot count word. So count word should plus equal to 1. Yeah. So this is the insert. After inserting everything, we're gonna count the word equal to this word. Yeah. So similarly, I'm gonna copy this 2 line. It's gonna be the same. Yeah. So current should be equal to self.root, and for character inside the word, if say not in current.children, what are we gonna do? Yeah. So for example, if we code some word, for this example, this is like apple or something app, but we code some word, for example, we code a banana with B. B is just not inside. So if it is not inside, immediately we can return 0. If it is inside, we're gonna shift the current should equal to current.children with this character. And finally, we can return this count, current.count word. Yeah, so this is finally we can return this count word. So this is the count word equal to this word. Yeah, we just need to count how many of them. If it is not inside from somewhere, for example, from here, if this character is not inside, even not inside, so we're gonna return 0 immediately. Otherwise, we're gonna count until to the end. If we can count it to the end, it means there is a word, so we're gonna return current.count word. It means this gonna be, this gonna be at least 1. But if we already erase this word, maybe this count is just 0. It always depends on if we call this erase or not. Yeah. Now let's continue to use the prefix. So the prefix is just copy the same code. We just need to change this 1 to prefix. So for character inside of the prefix, if it's not inside current.children, we're gonna return 0. Otherwise, we're gonna shift until to the end. Yeah, let me check. It's gonna be a little bit different. Because here we're gonna count the prefix. Yeah, so here it is called prefix. Yeah, it's the same as you can see until we count to the end. And finally, we just need to return current.count prefix. Now let's go to the final part. It is the erase. Yeah, we just needed to erase 1 by 1. So how to erase? So for character inside the word, this is a word. And we're gonna erase 1 by 1 because definitely this word is inside of the try. We can erase it. So for character inside of the word, current should equal to current.children with C because definitely there is. And current dot, we're gonna first delete minus the code prefix by 1. And finally, if it jumps out of the for loop, we can call to the word minus 1. Yeah, because this is erase. This is the entire code. Yeah, I think it is long because it's like 40 lines of code, but it's not so difficult because if you know the basic data structure about this try, because it is just starting from some node, it is a tree structure. Yeah, it is a kind of a tree structure, but this try, for example, C or D or something, this is a kind of a tree structure, but we used the dictionary to represent the try, because if you are using a tree, as we know, we're going to use the tree node dot left and node dot right, that is okay. But there are so many children, it is 26 children, for example, it is the English lowercase letters. So we cannot use a left or right node. We have to use some data structure, a hash table, for example. It is easy to store all its children because there may be 26 children, so we're going to use the self.children. This is the only difference. But this is just a trie node. So this node not only have the dictionary as its children, but also have the two variables, called word and called prefix. Now let me submit it to check if it works. As you can see, it works and it's pretty fast, because the time complexity is just on times m. N is the length of the prefix or length of the word, it is 2000, and m is the number of calls, it is 3 times 10 to the power of 4. Thank you for watching, see you next time.